let's say path. We have used path, so let's say possible path. So since we filtered neighbors, now we have to find the possible path. Actually, possible paths will be better, not path. So we want to move if we find a possible path, right? So if we find, let's say the source is A, and we found the possible paths B and C, then we want to move to B and C and call recursive function again. So first of all, let's use list concat here, and I'll explain about why we're using concat later. So first of all, function x to y. First of all, if we found the source in the first one of the tuple, then we have to call function again with graph, but now this time we have to call with y instead of source because we have moved to. So let's say we have found A and it's just x, which means x equals to A, then we want to move to B, and now we want to find the neighbor of B's, so we need to change current source node to y. And now since we visited A, we need to add A to visit it, and since we have moved to y, we need to add y to path. Yeah, it's simple, right? Or if so, this case, if so, x not equals to A, which means we have found source in y. So this means we have found source is in x, or first of source is in first, and source is in second. This case, so we need to call path helper again with same graph, but this time we have to change source as x because let's say source is C, then we have moved to D, which is in the first position in the tuple. So we need to pass x to new function, new recursive call, and call B again, and then let's say A visited, let's add A to visit it just like that, and x to path because we have moved to x. So we have moved from C to D like this. So we're going to use possible path with neighbors, and we are going to call possible path like this. So list concats here is concatenating this one together, this whole thing together, and list.map is mapping this function with neighbors. So yeah, this is all of the code, all of the path helper. So if you don't want to use helper function, then you can put this whole function in path, but for readability, I just separated them. So by doing this, you can find your graph path in an undirected graph.